Hello everybody, my name is Parthodas and I welcome you to my channel where we break down the complex DevOps and networking concepts into a simple practical lessons. Today we are diving into Docker networking, which is one of the most fundamental topics. When I started Docker a few years back, I always wanted to know how the container communicates with each other and the outside world. And why does each Docker container consist of something called Docker Zero Bridge Network? So if you also have the similar kind of questions in your mind, let's learn it together. But before we proceed, I just want to set up the agenda. And I have divided this video into three consecutive days so that it becomes easy to follow up. On the day one, we'll understand what is CNM, what is libnetwork. So these are the few terms that we always hear whenever we talk about Docker or any containerization, because CNM is one of those most important concepts that we have to understand. So we'll talk more about this. It is going to be a theoretical section and with having little bit understanding how this comes. Okay, so before we jump into Docker, CNM or libnetwork, let's understand the network as a whole. So for an example, if we have two devices, let's try to simulate what actually container is trying to do. So say we have two laptops. We are not talking about the container or Docker now. We're just thinking how we can make these two laptops communicate between themselves. Because it is a two laptop, how we are going to make a communication. There should be somewhere we can connect in one end of the laptop and the other end should be connected with something. Now that is where the main concept starts. So that's where we have to think what are the components is needed for this to communicate. The first thing that we need is the laptop should have some kind of hardware in this or some kind of interface in one of the laptops, and the same interface, similar kind of interface should be there on the other laptop, right? So once these two interfaces are there, we can get some kind of help from the external and we can make them connect just like that, and that's how they can communicate. Now the question is, what are these two components, hardware, and that hardware name is the interface. Okay, and now when I'm talking about the interface, there are two kinds of interfaces. One is called as onboard interface. That's why, like, let me write it. So one is called the onboard, another one is called the PCI slot based, right? PCI slot, we can think of just like that. Okay, now what is the meaning of onboard? So when I'm talking about the onboard, as you know that each and every laptop or device has a motherboard. So when the interface is directly embedded into the motherboard, that's called the onboard based interface. And another one is a PCI slot. So in the PCI slot, it is basically a plug and play kind of interface which I can directly attach into the laptop through a slot. Now based on this slot, if you see, it has something called as O, another one is having P. So if I remove that, it becomes like O and P. Now since it is connecting to the interface, so we know that the interface is either it starts with EN, right? So I can write it like, ENO, or it can be in the name of ENP. This interface is embedded into or connected directly into the motherboard. And the other one, if you see this ENP, that means it is a PCI slot based interface which is plugged into the laptop. Okay, so please remember this naming convention, because based on this naming convention we'll be seeing a lot of things. The first component that has to be there is the network interface, which has to be installed on that particular hardware. Okay, so let's write it. What are the things that we need, right? So first we need an interface. Okay, and the second, what you need is we need a cable. Okay, we need a cable, and this is the cable which is making this connection possible. So let's write it down. So the second thing that we need is a cable, and this cable is basically an Ethernet cable. And why it is called Ethernet cable? Because it is connecting to these devices through RJ45 cable, and each and every RJ45 cable has two ends, and both the ends there is something called RJ45 connector. So one connector connects here on this end, another connector will be connecting to this end. So that's how these two are now able to communicate. But is this the end? No. Now what happens if in my network I have one more laptop? Now how am I going to establish the connection? That's where the main question comes into the picture, and that is where the extensibility of network comes. So this was fine if there was only two laptops, and but when more than two laptop comes, it will be little difficult because I have to maybe I have to put some another interface on this laptop, I have to put another interface on this laptop, and maybe I can make 3 laptops to connect. But what will happen if the laptop number of laptop increases to 4? Is it difficult? It is really difficult, right? So we have to increase the number of connectors there, and it is going to be a mess. So to save from all those things, we need something called as layer 2 switch. Layer 2 switch. Now why it is called layer 2? Because it actually each and every switch has a lot of ports in that, and each port communicates with another port based on the MAC address, and we know that MAC address comes under the second layer of the OSI. That's why it is called as layer 2 switch. Now what we'll do, as is told, each and every switch has a lot of ports, 16 ports, 32 ports. There are different ports. Switches are there based on the model number on which vendor we are purchasing it for. So for our purpose, let's say it has around 10 ports or 16 ports. So what am I going to do here now is, rather me connecting this laptop with this laptop just like that, I'm going to take that connector, one end of the connector from there, and put it to this. Right, so say for example, this is connected to on the switch on the first port. Similarly, this one connected to another port. Similarly, this one connected to another port, and similarly this one connected to another port. Okay, let's put it here. Okay, now it makes sense. Now if you see this is one of those network topologies, and that topology is called star topology. Since these all laptops are communicating among themselves through the switch, that means all these network devices are on the same broadcast domain. Now if you see this laptop is communicating with this laptop because it has an interface that is matching over the first point. Second point, it has to communicate to the switch, and that's where it needs an Ethernet cable. That's where the Ethernet cable is coming. So we call that as an endpoint. Okay, and the third thing, which is the most important thing, is the switch, or that we can say as a network, or we can call as a switch. Now see, 1 and 3 are the most important, and if you want your laptop to connect to your switch, we need something called as interface, or sorry, endpoints, right? And that is the one components which is making this laptop communicate to the connect to the switch, and that's how they are communicating among themselves. Before we get into the CNM, let's take a small example, and that will definitely be helpful for us to understand what the CNM is doing. So imagine like you are trying to develop an enterprise-based software application. So what do you do when you think of doing some development of an application? Do we jump directly into the coding? No, that is not the best practice. So before we develop some kind of enterprise-based application, we don't jump directly straight into the coding, but what we do is we do something called requirement gathering, and after that we design the application architecture. And when I mean application architecture, this may include like UI design, it can be system design or database design, or the many other designs also we do, but these are the 3 things that we have to do. Okay, now once the design is finalized, then what we do is we move into the development implementation, and this is a very standard process for any software development. So this is the same thing even Docker followed. They followed the similar approach when designing how the containers should handle the network isolation. Now before building the network features, they first created a design model and include. So according to the CNM, every network container should have mainly 3 components. Okay, so let me just write all those things here so that it makes some sense. So the first thing, according to the CNM, it says that it should have something called as Sandbox. Okay, and the second thing that it says that it should have something called as endpoints. Let me write it down, then I'll just explain what is this meaning. All right, so and the third thing they want is they need a network. Okay, so these 3 things has to be there according to the CNM. Now what the Sandbox says is, the Sandbox says that network stack should contain something called as an interface. It should contain a route table. it should contain a DNS settings or DNS configuration. So this is what the sandbox says. Okay, and the endpoint, what it says is it's like a virtual connection point that attaches the sandbox. This attaches this sandbox with this network. Okay, so this is something basically connection point of sandbox and the network, and the network is the actual network where the communication happens. Okay, now if you see these three things, okay, and if you see these three things, it matches, right? So in our real physical environment also, in the real physical environment, we had an interface. We should have an interface. Okay, in interface we attach the IP address, DNS configuration, all those things happens here, and then we need a Ethernet cable that connects our interface to the switch and then the actual switches. This is the same thing, the sandbox. Now if we just try to relate this, the sandbox goes to interface, endpoint matches with cables or Ethernet, and the network is actual network which is matching. Now maybe you're finding some similarities, right? Why this sandbox, I mean these three components as per the CNM. This is as per the CNM, and this is on our physical environment, physical or the normal network environment. Okay, now once this design is completed, okay, so they have to, so let's make a design first, okay, before we move ahead. So according to them, there should be a sandbox. Let's say this is our sandbox, okay, and in the sandbox there should be some kind of in the sandbox there will be obviously some Ethernet interface or IP addresses or DNS configuration is there. So this is considered as a sandbox, and it should have something called as interface. So let's say this is our endpoint. Okay, now what the third point says, the third point says that it should have a network as well. Now where should we keep the network? This is a total, this is the host, right? This is the Docker host, and it should have a container. Okay, and every container should have an endpoint. And where the network should be inside the environment. So this is the network. So this is what the CNM says. It should have a sandbox, yes, done. It should have an endpoint, yes, done. It should have a network on the environment. So we have an environmental network as well. Okay, now once they have completed the design, the finalize the design, now they have to move into the implementation of creating an open source project, and that project name is the libnetwork. Now I hope, like, it's making some sense now. So they have created the design, now they have to start developing that. So what is the name of the development project? They have kept the name of the development project as the libnetwork. Okay, now what this project, so since it is a development project, right, so what this project is providing, the project provides an actual network logic, and it creates something called as driver. The driver is the one that Docker uses when it is creating a network. Okay, so once the design is completed, they have started a new project here. For an example, they have started a development project. There are a lot of software developers there. They started to do a lot of networking and all those things. Let's give it as a name as libnetwork. So this is the CNM part, which is basically the design part, and this is the libnetwork where a lot of developers are working, and they have created, out of that they created something called as drivers. Okay, now hope every dots are connecting now. This is the CNM model as per the CNM design. Libnetwork is the development project, and the drivers is the output or the product of the development project. Drivers are basically, one is the bridge driver, and the second one can be a host driver. And if you don't want any network, if you want to keep your containers isolated, you just say, like, I don't want any network, so give it none, or something like Mac VLAN. So Mac VLAN is something that we cannot reproduce in our cloud environment. It should have some kind of physical environment or data center that we can do it, but on the cloud we can manage bridge, host, or the net or the none. So to summarize it all, so CNM is basically a theoretical design of container networking. libnetwork is a practical implementation of CNM as an open source project. Now up to this, if it makes sense, I'm really happy that we have come a long way. And from the next video we'll get more into the hands-on, where we'll try to create the network into any Linux operating system, how to create a network. Then we'll try to simulate how we can create a namespace, and the namespace basically an isolated namespace for the network. Using like a netns command, we can create isolated network inside the Linux, and then we'll try to implement all the things that we have discussed here. Basically, we'll create a network and we'll try to communicate with the outside world. Inside the host, we'll be using the IP tables for that, and we'll see more in details on our hands-on session. So I really thank you for being with me for so long, so being so patient, and let's see together on the next video. Thank you.